Now in this lecture we are going to look at how can we delete a node from CircularDoublyLinkedList. By now you must be familiar that when we are deleting a node from any type of linked list, we have three cases, which are deleting a node from the beginning of CircularDoublyLinkedList, deleting a node from any given location in the linked list, and deleting the last node from the linked list. Now we are going to look at how these three cases work in case of CircularDoublyLinkedList. Now let's look at the first case. Now when we are deleting the first node from CircularDoublyLinkedList, in this case we have two cases. So the first case is we have only one node in our CircularDoublyLinkedList. So let's look at this case. Now in this case, to delete this node from CircularDoublyLinkedList, we have to delete the links that comes to this node over here. Now here you see that we have a link that comes from head, we have a link that comes from the tail, and this node is linked to itself with the previous and next references. Now the first thing that I'm going to do, I'm going to set previous and next references to null. Now if I set both references to null, the link to itself will be deleted. Now the next step is we are going to set head reference to null. So with this we are going to delete a link between head and node 1. So if I set head to null, the link between head and node 1 gets destroyed. Then I'm going to set head reference to null. So if I set head reference to null, the link from head to this node 1 will be deleted. Now after deleting all links, we see that this node is not referenced by any node over here. So this means that garbage collector can come and delete this node from here. So if a node is not linked by any given node in the memory, in this case garbage collector destroys it from the memory. Now with this we have successfully deleted first node from CircularDoublyLinkedList, in which we have only one node. Now let's continue to the second case, in which we have more than one node in our CircularDoublyLinkedList. Now in this case we have more than one node in our CircularDoublyLinkedList, so we have to delete this first node from CircularDoublyLinkedList. So as we mentioned before, here also we have to delete the links that comes to this node 1 over here. Now you see that we have a link from head to this node 1, and we have a link from last node to this node 1, and we have a link from node 2 to this node 1 over here. Now after deleting node 1 from this CircularDoublyLinkedList, node 2 will be the first node in our CircularDoublyLinkedList. So this means that we can just update these references to point to node 2. So with this we can successfully delete the links that comes to node 1 over here. Now the first thing that I'm going to do, I'm going to update last node's next reference to point to node 2, because in this case it points to the node 1. As you can see here, the last node's next reference is 001, which is node 1's physical location. So in this case I'm going to update it to 111, which is the physical location of node 2. Now if I update it to 111, it creates a link between node 4 and node 2, and a link between node 4 and node 1 gets destroyed. Now the next thing that we are going to do, we are going to create a reference from head to node 2. So with this we are going to delete a link between head and node 1 over here. So I'm going to update head to the physical location of node 2. So the physical location of node 2 is 111. So if I set it to head, it's going to create a link between head and node 2, and a link between head and node 1 gets destroyed. Now as you can see, we have deleted the links that comes to the node 1. Here we have left only with this link. So we have reverse link from node 2 to node 1. So we have to update node 2's previous reference. So here you might be interested that what we are going to update here. So here, if the node 2 becomes the first node in our CircularDoublyLinkedList, in case of CircularDoublyLinkedList, the previous reference of first node has to point to last node. So in this case, the last node's physical location is 333. So I'm going to set it to 333, and with this we are going to create a link between node 2 and node 4 over here. And with this, a link between node 2 and node 1 gets destroyed. Then as you can see, this node is not referenced by any given node, so this means that garbage collector can delete this one from the memory. So it will be successfully deleted. Now after deletion, you can see that node 2 becomes the first node in our CircularDoublyLinkedList, and head points to the node 2, and last node's next reference points to node 2, and node 2's previous reference points to last node. So everything implemented successfully. Now let's continue to the next case, in which we are deleting a node from any given location. Now let's say we want to delete node 3 in this case. So in this case, as always, we have to delete the links that comes to node 3 over here. Now how can we delete for example, a link between node 2 and node 3. So we have to find the node 2's location. Then from here, we can delete the links between them. So to do so, the first thing that we are going to do, we have to loop through the circle double linked list until we reach this location. So if we come to this location, we are going to stop over here. Then we are going to update the next reference of node 2 to point to the node that comes after the node that we want to delete. So we want to delete node 3. So in this case, we want to point it to node 4. Now node 4's physical location is 333. So I'm going to update node 2's next reference to 333. So this will create a link between node 2 and node 4, and a link between node 2 and node 3 gets destroyed. Now the next thing that we have to do, we have to update previous reference of node 4 to point node 2 over here, because in this case we have only one link that comes to node 3, which is reverse link from the node 4. That's why we are going to update node 4's previous reference to 111, which is physical location of node 2. So in this case, if I set it to 111, it creates a reverse link from node 4 to node 2, and a link from node 4 to node 3 gets destroyed. Now with this, you see that node 3 is not referenced by any given node, so this means that it will be deleted from the memory. Now after deletion, our circular double linked list will look like this. So as you can see, third node is deleted from here, and the fourth node becomes the third node in this case, because second node points to the fourth node over here. Now with this, we have successfully implemented this case also, in which we are deleting a node from any given location in circular double linked list. Now this case is same as the case of double linked list, because here we are not doing any extra steps to delete a node from circular double linked list, which is located at any given location. Now last case is we want to delete a node from the end of circular double linked list. Now in this case, we want to delete last node. Now here also we have two cases. The first case is we have only one node in our circular double linked list, and the second case is we have more than one node in our circular double linked list. Now when we have one node in our circular double linked list, it is the same as deletion of first node in circular double linked list. So here again, we are going to set previous and next reference of this node 1 to null. So with this, we are going to delete a link that points to itself. Then we are going to set head reference to null. So with this, we are going to delete a link between head and node 1. Then we are going to delete a link between tail and node 1. So we are going to set tail to null. So this one will delete a link between head and node 1 over here. Now after deleting all links over here, node 1 becomes eligible for garbage collection. So garbage collector can delete this one from the memory. Now then, we are going to continue to the second case, in which we have more than one element in our circular double linked list. Now here, if you want to delete last node from the circular double linked list, after deletion of last node, so the last node will be node 3. So this means that tail has to point to node 3 and first node has to point to node 3, and from node 3 we should have a link to first node over here. Now the first thing that we are going to do, we are going to update the tail to point node 3 over here. Now the node 3's physical location is 222, so now tail points to node 4, so it has to point to node 3. So if I update tail to 222, in this case it will create a link between tail and node 3 over here. And a link between tail and node 4 gets destroyed. Now the next thing that we are going to do, this node has to point to first node over here. Now we know that in case of circular double linked list, the last node has to point to first node. Now in this case, we have to delete a link between node 3 and node 4. So if I update the next reference of node 3, a link between node 3 and node 4 gets deleted, and a link between node 3 and node 1 will be created. And node 1's physical location is 001. So this means that if I update the next reference of node 3 to 001, it's going to create a link between node 3 and node 1 over here. And a link between node 3 and node 4 gets deleted. Now the last thing that we are going to do, we have to create a link from node 1 to node 3 over here, because previous reference of first node in case of circular double linked list has to point to last node. So after deletion, node 3 will be the last node. So this means that we have to update the previous reference of node 1 to point to node 3. Now the physical location of node 3 is 222. So if I update node 1's previous reference to 222, it will create a link between node 1 and node 3 over here. And a link between node 1 and node 4 gets destroyed. Now after doing these updates over here, we can easily see that node 4 is not referenced by any node. So this means that this is eligible for garbage collection. So garbage collector can come and delete this one from the memory. Now with this, we have successfully deleted a node from the end of CircularDoublyLinkedList, and a node that is located before the last node becomes last node in CircularDoublyLinkedList. So here we can easily see that first node points to this node, and this node has a reverse link to the first node, and tail also points to this node. So everything is implemented successfully. Now with this, we have come to the end of this lecture. So in this lecture, I have explained you how can we delete a node from CircularDoublyLinkedList. So as we know, when we are deleting a node from any given type of linked list, we have three cases. So we have to delete the first node separately, the last node separately, and a node from any given location separately, because the logic of these deletions are separate. Now in the next lecture, we are going to combine all these three cases together in one algorithm to make our life easier for creation of deletion method in practice. Now see you in the next lecture.